there, folks. Today we're looking at constructing parallel and perpendicular lines. And just a reminder that constructions are essentially just drawing geometric figures using only a compass and a straight edge. All right, and we've done basic constructions before. Remember, we'd copied line segments, we copied angles, we bisected, we did perpendicular bisectors of lines, we did bisectors of angles, some of those basic kind of things. And we'll use some of that today as we deal with constructing parallel and perpendicular lines. But the first one we're going to do, we're going to construct a line that's parallel to another line through some given point. All right. So the first thing I have here is I'm given that I have line M, so some line, and some point A that's not on the line. All right. So a line and a point that's not on the line, and I have it drawn down here. But we can see line M and we can see point A not on the line. And so all I'm going to do is I want to construct a line that's parallel to M that goes through point A. So the first thing I'm going to do is I'm actually going to draw a line that intersects line A and line M. And this is just going to give me a basis for creating the parallel line. And it doesn't really matter where I intersect this thing. Let me change the color of that. I meant to have it in a different color, but it just didn't work. There we go. Just so we can see it a little bit better. So I just connect these, and again, it doesn't matter where I intersect on M as long as I intersect M and I go through point A. All right. So what I've done is I've essentially created an angle here, and now what I'm going to do is I'm essentially going to copy that angle. All right. So I'm going to copy the angle that I've just created, and this is where my compass comes into play. So remember, to copy an angle, the first thing I do is I just kind of strike an arc along this somewhere. All right, so I strike an arc along this angle. All right, so I've struck an arc along the angle. And then what I do is I strike the same arc, and since I want to use A as my vertex, I'm going to place my compass on the value of A, and now I'm going to strike that same arc. So I strike that arc up here somewhere. And now from here I have to measure across that arc. So when I come back down here, I basically put my compass on one point of intersection from the arc, and then put the other end on the other point, and I'm pretty close here. Let me extend this just a little bit. Alright, so I measure across that arc, and now I just transfer that measurement up top here. So I put my compass on that point of intersection, and I transfer this measurement up here. And now once I have that measurement transferred, I'm essentially just going to draw a line that goes through point A and through that point of intersection that I've created. So if I draw this line through those two points, what I end up with is I end up with a line that's parallel to M. So essentially what I've done is I've copied an angle, and when you think about this, if these two lines are parallel, all right, the line I have in green and the line I have in, well, actually, let me change the color of this line to make it a little bit more obvious. But if I compare the red line and the original line, they're parallel because I copied a corresponding angles. I made corresponding angles the same. I made them congruent, and that's what creates a parallel line. And that's it. If I looked at something like this, it asked me to construct a quadrilateral with one pair of parallel sides of lengths A and B. So I want to construct a quadrilateral this time, and I want two of the sides to be parallel, but I also want them to have a specific length. All right. So the first thing I do, if I want a line of a specific length, is I first just draw a line or a ray. And then I transfer the measurement from something like segment A. So let me grab my compass so I can transfer this measurement. That is not what I wanted to do. I'm still drawing lines, apparently. Here we go. So remember, to transfer this measurement, I just measure A using my compass. And now I transfer that measurement down here. So now what I have is I have a segment that has a length of A. So this segment right here is length A. And now from here, I want to create a line that's parallel to this one that has a length of b. So I'm going to create a line that's parallel. Remember, to create a line that's parallel, I first just draw I'm going to start with some kind of point out here in space somewhere. So maybe I'll call this, this is the point that I want maybe. Alright, so that'll be the point that I'm going to deal with. And I just draw a line that connects that point and intersects the line that I'm given. And it doesn't matter exactly where this thing intersects, but now what I'm going to do is I'm going to end up copying this angle. Alright, so I'm creating corresponding angles that are the same. So in order to copy this angle, I once again just strike an arc across the angle. Come over here and I strike an arc across here. I transfer that arc. And now I measure across this angle. Well, it looks like I'm just about spot on in terms of the measurement here. So now I transfer that measurement. And now I can draw my parallel line. So I draw a line that's parallel. So there's my parallel line, but I want that line to have a length of b, so once again I use my compass to measure the length of b. And now I just transfer that measurement. So now that bottom piece has a length of b, the top piece has a length of a. I just need to construct the last side of this quadrilateral by connecting these 2 points. And there it is. So we see the quadrilateral in here, and I could try to condense this a little bit and maybe change the lengths of these and really show the quadrilateral if I start scooting if I were to be able to erase pieces of these lines. We can really see the quadrilateral start to come together as I kind of shorten up these pieces. But we end up with a quadrilateral that has 2 parallel sides and has one side that has a length of a and one side that has a length of b. And there it is. Now we can see my quadrilateral after I've gotten rid of the rest of the stuff. Now we don't have to erase those marks, but just so you can see the quadrilateral a little bit better here. If I look at something like this, the perpendicular postulate, very similar to the parallel postulate. The parallel postulate told us that if I have a point that's not on a line, there's exactly one parallel line that goes through that point. And this one says kind of the same thing, but in terms of perpendicular lines, if there's a point not on the line, so through a point not on a line, there's exactly one perpendicular line to the given line. All right. So through point P, if I look at the example down here, through point P, there's exactly one perpendicular line that can be drawn. And no others. And we can see it right away. As soon as I draw a perpendicular line through that point, we can see that that is the only perpendicular line that goes through that point. There are no other perpendicular lines that I could draw. All right, and that's what the perpendicular postulate is telling us. So if we want to construct a perpendicular line through a point, here's what we do. So I'm given line M and point A not on the line once again. And so what I want to do is I want to create a perpendicular line through this. And really, we're going to use perpendicular bisectors to do this. That's the construction that we're familiar with previously. And so the first thing I do is I'm going to strike an arc across M from point A. All right, so I'm going to go to point A, and I'm going to strike some arc across M. So here I am on point A, and I'm just going to strike an arc across M. I'm going to extend this a little bit. But I strike an arc here, and I could keep that going. And if you want to strike it all as one arc, and I'm also going to strike an arc here. All right, and I cut it pretty close there in terms of being off the line a little bit. But what I've created here is I've basically created a segment. When I look at these 2 arc pieces, I've created a segment where A is at the center of this segment because I measured the same distance from A. And so now from those 2 points, I'm going to create the perpendicular bisector. If I go to this point, remember I just need to be at least halfway across here. I just strike an arc above somewhere, and I strike an arc below somewhere. And again, we can strike this as one continuous arc. I just don't like having that all over the place. And now using the same arc measurement, I go from this other point. And the intersection of these arcs, and again, you could draw it all as one arc. I just like doing it in two little pieces. But now when I take that and connect those points, that's my perpendicular bisector. So if I connect these points, there's my perpendicular bisector, and you'll notice right away it goes through A. I've created a perfect perpendicular bisector based on those arc measurements, but it created a perpendicular line that goes through A because A was at the center of this thing, and that's why I strike those arcs to begin with. Okay? Looking at the same thing in the next one, except slightly different. This time it asked me to construct a perpendicular line through A, but the difference is that A is actually on the line this time. And so since A is on the line, really it's almost no different. The very slight difference is in that I essentially just go from A that's on the line and I strike an arc on each side. Really it's a little bit more obvious this time because as I strike each of these arcs, it's very obvious that A is in the center of this because I measured the same distance in each direction. Alright? But now I go through the same process where I create the perpendicular bisector. So if I measure from here, and again I got to be at least halfway, so I'll just go a little bit further. I can strike one continuous arc. I'm going to strike an arc up top and an arc down below. I like to do it in two pieces. And now I do the same thing from my other point. An arc up top and an arc underneath. And I'm going to find out that when I connect these two intersections, what I end up with is a perpendicular bisector, but it's only a bisector based on those points that I have drawn on the line. So for our purposes, it's just a perpendicular line that literally goes through point A because I put point A at the center of those values that I used to draw the perpendicular bisector. All right? So I get this perpendicular line that cuts through point A. And so again, it's very similar to the previous example where we're essentially using the compass to put two marks on the line that puts A at the center, and then I do my perpendicular bisector. Okay?